Welcome guys to a new video. This is a paper 1 model, question 1. A player throws a basketball. The height of the basketball is modeled by the following function. H is the height of the basketball above the ground in meters, and T is the time measured in seconds after the ball is thrown. Question A. Find how long it takes for the basketball to reach its maximum height. Okay, so these kinds of questions I like to solve using the graph. You can also use algebra if you like, but graph makes it much faster, so make sure you have your graphic calculator with you. The first step is to plot the function on the calculator, and you click the graph option on your GDC and then plug in the function over there, and you should see the result. I'm just gonna put here the actual graph, how it looks. Now XY is what the calculator shows. However, for our context, please remember that the input is actually time and the output is actually height. Okay, so it's gonna look like this. This should be the graph of your function. The question was to find out how long it takes for the basketball to reach the maximum height. Maximum height is at the vertex over here somewhere. Now, how do you find the maximum using the graph? Well, in order to do so, you can also use the calculator. So there is the analyze graph. You want to analyze graph, and then you're going to choose maximum. As you select your maximum point on the graph, you will see the answer. So you want the time it takes, you want the x-coordinate. The x-coordinate in this case is going to be 0.921. So the answer for part A is 0.921 seconds. Now let's look at part B. Part B says the following: assuming that no player catches the basketball, find how long it takes for the basketball to hit the ground. The ground, as you can imagine, is over here. This is the ground on the x-axis. So here's the basketball, somebody throws it, right? It flies in the air until it hits the ground. The question is, how long did it take to get to this point? In quadratic functions, we call this a zero, right? The x-intercept is also called a zero of the function. Now, on the calculator, on the same graph, you can analyze graph, use the same tool, and choose the zero. As you select this point, you'll have the answer, and the answer will be 2. So 2 seconds is the answer for part B. Look what I do, I just use the graph method. Another player catches the basketball when it is at a height of 1.2 meters. For question C, find the value of T when the player catches the basketball. Okay, so we want to think what happens as somebody catches it at a height of 1.2 meters. For question C, I will make use of the same diagram from here. 1.2 meters, let's assume it's over there. Now, how can you actually do this on the calculator? This is how you do it, guys. You just click tab so that the calculator gives you the option to put the second function, F2. Now, in the second function, all you have to write is 1.2. So when you write a number, the calculator will draw a straight line at that number. Now, 1.2 is the height. What's the value of t, the time, corresponding to this height? That's something you check on the calculator again by using intersection. This is a point of intersection between the straight red line and the curved yellow line. So the intersection is going to give us the answer for question C. That answer is going to be 1.88 seconds. Okay, and then for question D, it asks write down one limitation of using h of t to model the height of the basketball. Well, one limitation would be that we are not considering air resistance. So the model does not consider or does not account for air resistance. Air resistance.